Hey everybody, it's Ripley again. Welcome back. I am not going to lie to you. Chain rule, I'm not speaking in hyperbole here. I am being as honest as I possibly can. Chain rule is the most important rule to probably all of calculus. If you don't understand chain rule, if you don't take the time to really commit to learning it, you're dead. Okay, the most important thing to know about chain rule, and this is kind of a Ripley colloquialism, is chain rule is part of every derivative you will ever take. It's part of every derivative. Now, let me show you, whoa, derivative? Oops. Let me show you just really quickly part of every derivative. Now, why this is true. Let's just say for a sec that y equals, keep it simple. Let's go x squared plus 5 squared. Now, remember, if I take the derivative of x to the n, I get nx to the n minus 1. So our more fledgling mathematicians, calculisticians, whatever, might look at this and go, oh, well, this is easy, Ripley. This is a piece of cake. I simply go 2 times x squared plus 5 to the first, and I'm done. Well, the problem here is we have a composition of functions. We have a composition of two functions. I mean, think of this as f of x equals x squared and g of x equals x squared plus 5, right? So really y equals f of g of x. In other words, I'm sticking x squared plus 5 into x squared, and I get x squared plus 5 squared. Okay, now let me show you what happens. Let me show you how this plays out, because this is wrong. Oops, this is wrong, and you'll see why. Watch. If I foil this guy out, I mean, I get x squared. This equals x to the fourth plus 10x squared plus 25, right? I mean, just simple FOIL, x squared times x squared, x to the fourth, 5x squared plus 5x squared, etc., etc. Now, the derivative of that is equal to 4x cubed plus 20x, which if I factor a 4x out, this is 4x times, what, x squared plus 5. Now, look at what we were off by. Remember, I'm going to rewrite this just so you can see it. 2 times x squared plus 5. Well, look close. I am off in this correct answer by a factor of 2x. In other words, if I take this guy and multiply it times 2x, let's get rid of that, I would get the correct one. Well, what do you notice that 2x is? It's the derivative. It's really the derivative of this whole guy right here. Now, let me show you how this really plays out. Here's the problem. You may say, well, Ripley, okay, I can just FOIL everything out. I mean, I can just take x squared plus 5 squared and FOIL it out and take its derivative. I'm not afraid. Okay, well, that's really cool, except if you've got, let's see, x to the 5th plus 9x plus 3, and let's raise it to the 10th. Now, I don't know about you, but I'd rather saw my own toe off with a spoon than have to multiply this trinomial out times itself 10 times. So watch how chain rule works, and then I'll give you the formula for it. Okay, watch. What we say is we've got a composition of two functions. So I'm going to think of y as being f of x equals x to the 10th, and then g of x equals x to the 5th plus 9x plus 3. So y is equal to f of g of x. So really, ladies and gentlemen, what chain rule is, we have a product rule, we have a quotient rule, we have a sum, and we have a difference rule, right? We've basically got all of the operators except composition. Chain rule addresses composition. That's what it does. All right? Now, watch. When I take the derivative of this composition of functions, what I do is I simply take the derivative of f and with g just kind of crammed in there. But then I respect the fact that it's a composition, and I take g prime of x. So let me show you how this plays out. In my brain, and I'm going to drive you guys nuts with this, but that's part of my job, I think of this as being a blah to the 10th. And the derivative of blah to the 10th is just 10 blah to the 9th, according to this rule. 10 blah to the 9th. I'm not afraid. Well, my blah is really just x to the 5th plus 9x plus 3, right? So it's that to the 9th. However, I then have to tack on a d blah. I have to take the derivative of that composed function. And those derivatives link themselves like links on a chain. You got it? So I need to take the derivative of x to the fifth plus 9x plus 3, which is 5x to the fourth plus 9. Now there's a real simple algebraic proof to this, and let me show you how this works. dy over dx. Do you agree that if I wanted to, I could rewrite dy over dx as dy over du times du over dx? My du's would cancel and I'd get this guy, right? There's an identity there. So really, if you think about it, what's happening here is instead of f's and g's, what I have is a y and a u. All right, let me put it into play. Let's say that f of x equals the sine of x squared plus x. Okay, let's say that. Now, what is this? This is what I refer to as my blah. But mathematically speaking, it's really my u of, it's my u. Okay, so I'm going to call it u for just a sec. So I'm going to rewrite this as the sine of u. So think about this. I know notationally this is a little bit muddled, but I'm simply going to write this as y as a function of u. Okay? Now, according to this, remember we started out as y as a function of x, true? According to this right here, this guy right here tells me that the derivative of this, which I've rewritten like this, says take the derivative of y as with respect to u. So I take dy over du, which is just the derivative of this guy, which we know is cosine of u. But then I have to take the derivative of u with respect to x. Well, let's write up what u of x is. It's x squared plus x, right? So dy over du is cos u. Du over dx is just the derivative of this guy, which is 2x plus 1. So I know that dy over dx is equal to dy over du. Let's see, that's cosine of u times 2x plus 1. Be careful with your parentheses. But Ripley, what the heck is this u doing here? Oh, whoa, wait. Oh, we called u x squared plus x. So this becomes the cosine of x squared plus x times 2x plus 1. Typically when I write these, because my ADHD starts to flicker when I see chunks like this, so I'll typically write this as 2x plus 1 times cosine of x squared plus x. Otherwise, I might be tempted to think that this is part of my angle. All right? Now, like I said, chain rule pops up everywhere if you really think about it when I take if y equals x to the fifth. Dy over dx is equal to 5x to the fourth, right? But it's also times a 1, because what I'm doing is I'm taking an x and I'm sticking it in there and raising it to the fifth. I'm composing x into x to the fifth, and the derivative of x is 1. You've been using chain rule over and over and over again. You just didn't know it, which is kind of cool. All right, so let me give you a couple more rules, and we'll do a few examples, and then we're just going to start doing a ton of derivatives. We're going to do a boatload of these, okay?